Justin and Alex, and we are from Malay Constructions. And today we will be telling you why we think our design of a transport system would greatly benefit the people of the Mayuko Yuka camp. So, given that 90% of the income for the camp comes from agriculture, it's safe to say that the transport system used to transport said agricultural goods needs to be efficient, and the current transport system just doesn't cut it. Currently, they use an ox-drawn cart, which for a few reasons is inefficient, but mainly due to the harsh weather conditions that lead to terrible ground conditions. For example, when the weather is too dry, the ground becomes too soft and very difficult to pass on. Conversely, while the weather is too rainy, the ground becomes too muddy and almost impassable. Another form of transport that's aplenty at the camp are bicycles, but are rarely used for transport of agricultural goods. So what we have decided to do to be cost efficient would be to use bicycles that are available at the camp and connect it to our design carts to make a cost and time efficient form of transport for the camp. We have identified 5 stakeholders for our project, 3 primary and 2 secondary, namely farmers, cart owners, families, merchants, and cart builders. All these stakeholders will be positively affected by our project, except for the possibility of cart owners who might see our project as taking away from their business. But what we can do to oppose that would be to use bicycles that they own and collaborate with them as in making our design, which would turn them into a positive stakeholder as well. I'll pass it on to Brian for SWOT analysis and refinement.
By now you should be wondering what difference does it make from this card and the one that currently exists in Mayuko Yuka. From this card you can see that it chooses the D-LED system, which is attached to the bike, and this allows for us to use any bike around, so which makes it very easy to operate, since you can take any bike from Zimbabwe, South Africa, Australia or Zambia, then you put it here, then you can operate it. And also this card, as you can see, it has the third wheel, which is very small. This one allows it for us, let's say they're going that way and they realize that they left something, so they can simply turn it around, then they go the other way, which makes it very easy to operate as well. So from this card, you can see that it will be basically made from galvanized steel, which is very cheap, and some hinges, and screws to make it. And also from the design of the cart, you can see that this part is firmly attached to the cart, so which makes this cart very hard to turn on sharp corners, so you know that nothing is 100% perfect. So for that, we can replace this part with a hinge, which allows it to bend on the side so that they can go on sharp corners. But at the same time, the capacity of this cart is about 1.08 meters cubed, which is very small. So if the people in Mayuko Yuka think that this is very small, they can just expand it and it fits their size. And basically the wheels and everything, it makes this cart a fast cart to navigate in Mayuko Yuka.
So now to address the sustainability concerns with our design. Firstly, on the environmental side, the design primarily consists of steel, which is a highly recyclable material, and this is because it does not lose any of its physical properties during the recycling process. As such, it is the most recycled material on the planet. The reason steel is favoured as a material is because it's a very strong, high quality and durable material, and it has a much longer lifespan than any other alternatives available. Because of this, the design is built to last, and you'll not need to worry about replacing parts due to wear and tear for a very, very long time. In the case that the need does arise, the steel can always be replaced with wood, which is available in abundance in the local environment. Economically, the design, all the materials are affordable and very simple to construct. As mentioned before, it amounts to a total of approximately $137 for 1 unit. Maintenance-wise, there'll be a very low-cost, long-term project. This is once again due to the durability and recyclability of steel. Aside from maintaining and repairing the product itself, there'll be no extra funding needed to fund the cart. Technically, as you've seen, it's a very simple design. This means that there won't be very much technical know-how required to operate or construct this. That coupled with the detachability of the components, the bike from the trailer, means that the design is more adaptable than others. This is because you can upgrade by component without needing to overhaul the entire design. If a better bike or a more sophisticated vehicle becomes available, you simply attach that. If you want to upgrade the wheels on the trailer, you can do that with ease. There's a lot of potential for expansion and improvement on this design. In addition to this, the cultural sustainability, the idea of the design is to take elements from what already exists in Maikoyukwa and build upon this. And because of this, there won't be much of a change imposed from the locals in terms of culture. In addition to this, the materials used or the labour involved is not going to contravene any cultural beliefs, so there shouldn't be any issues in that regard. Ryan?
So for safety, since we're using galvanized steel, we're not corrode easily, making the less chance for cracking, as well as the quality of brakes on the bikes that are in the camp are what we're using, so it might be low, but because of the adaptability, we could change it very easily. In conclusion, we think our design would greatly benefit the people of the Maikoyukwa camp because of its adaptability, time, and cost efficiency. Thank you. And questions would be to these two gentlemen.
You said earlier that your tubes are galvanized. Assuming that you include the maintenance cost, would you reckon as a long-term plan would be better to do something that is already corrosion resistant instead of something that's galvanized and keep taking the annual over time?
Well, our cost, we've cost material used galvanized steel, so I guess we could take that in as an option to possibly reduce the cost of that design, but that cost that we've got is including the galvanized steel already. So.
Yeah, our cost is already we think pretty low, so that could be included into maintenance cost, which we're predicting will be about $50 across 5 years, excluding any random events like vandalism or something like that. So I think if we incorporated that, I think we would still have a very cost-effective design.
Yeah, at the beginning you said that the terrain was really hard for the oxen carts to travel due to soft sand, muddy terrain. What do you think, like, the difficulty of riding a bike with two very thin tyres through those conditions are going to be like? Do you, factor in the fact that a bike is going to struggle going through soft sand and stuff like that?
Okay, so we looked up most of the bikes around are mountain bikes, which are exactly designed to go through that sort of thing with very low gearing. So we believe that it would be able to make it through those sort of conditions. We've also implemented at the front of the design, the front wheel is actually a wheelbarrow wheel. So that is specifically designed for those type of conditions, getting through soft sand, mud, potholes. So we think